bubble away. Then we have, I've got some notes here about, you know, the seeds. These are basically seeds which are placed on the surface. Then we delete them after an age of 2. As they're bubbling, this is to give them a nice sort of randomness. While they're on the surface, they spawn particles at a rate of 1 per frame. Sorry, at a rate of 20 per second, which is, I think it's just about 1 particle, just under 1 particle per frame. Then the particles get sent onto here. You can see there's no shape in here, and there are no materials in here. And basically this is just set up to set up the seeds on the surface. There's no actual, if I just set this to display as a different type, let's try circles. You can see you've got these seeds here. And what I'll do is I'll just turn this off here. And now if I press play, you can see that the seeds are very, very random. They're appearing and disappearing. And that's just to give it this sort of nice randomness. The seeds never actually render. They're just used to spawn more particles, which are then rendered. So if I just turn this on again, the spawn particles are sent into here. There's a note here about, you know, turning off the shadow casting on the bubbles. We've got speed by surface, and you can see it's using the tablets. So in this case, it's actually using the position nearest to it on the surface, which actually defines the speed vector for that bubble. The bubble is basically fired outwards away from the surface, and that gives it a nice sort of fizzier look. We're using a speed of 60 and a variation of 40, so we've got a nice randomness to it. Then we're using speed by icon. You can see I'm using quite low values here. Acceleration limit of 5 and an influence of 10, and that means that this animated jiggle that we've got going on here doesn't have 100% of an effect of the particles. Otherwise we lost, you know, this initial pushing out from the tablet kind of effect, and it basically had too strong an effect, so we had to tone it down by doing that. It's using sync by event duration, so that as the particles are spawned into the event, that's when they start animating using this icon animation here. So you get this nice jiggling effect as they go upwards. Gravity, that's producing our buoyancy as I described earlier. Drag, again, you know, we've got drag in there to slow things down. Shape instance, we're using bubble static, and that's actually this bubble here, which you can see is called bubble static. That one doesn't actually wobble around because it's much smaller, therefore it doesn't have as much surface area, and it's basically a sort of stronger, more coherent bubble, and it doesn't jiggle around. You know, if you had a massive bubble, you know, which was, let's say, you know, 1 foot or 1/3 of a meter across under an ocean, you've seen how those really, really wobble around a lot, because they've got a much bigger surface area, and they're not quite as strong, as it were. Then we've got material static bubbles, which is our ray trace material. We've got a collision deflector, and that's basically just to kill off the particles when they reach the top here. And if they don't die when they reach that deflector, because sometimes particles get through a deflector, we then delete them based on age, so the particles aren't building up too much. If they do hit this deflector, they're sent down here and they're just deleted. All of the particles are deleted when they go down here. Now if I go back to the beginning and turn on this last effect, you can see this is called dissolved powder. It's basically the same kind of thing really as the bubble effect. The only thing which I've really removed is we've removed this speed by icon. That isn't actually needed anymore. We've got speed by surface, which actually fires. If I actually turn this on to, let's change it to circles as well. There we go. And if I press play, again we've got an animated amount, and you can see that in this case we're actually allowing the particles to, we're not using gravity, so there's no buoyancy on these particles. They're not bubbling up to the surface because they're meant to be powder. In fact, I think we're actually using gravity, but we've got a negative multiplier on it. So in other words, this is a bit perverse, but we've got a negative gravity to give buoyancy, so we're then using a negative influence on our negative gravity to make it into a positive gravity, so then it pulls the powder downwards. I hope that makes sense. It did when I did it at the time. So we've got our powder being pulled downwards instead of floating upwards to the surface. We've got our drag, we've got our speed by surface to give it that initial push out from the tablets. We've got our wind large and our wind small, and you can see in this case I've actually put them into separate force operators to give me control, exact control over the influence of them. I'm using a cube as the shape. Could have been a tetra. In this case, I've just used a cube. Material static, which is this dissolving powder material. I'm using scale relative successive, and I'm using a 99% value. So basically over time the powder actually shrinks in size, and that's to try and give the effect of it dissolving in the water. So it's meant to dissolve down to virtually nothing, and then it gets killed off. And you can see we're killing off all of the dissolving powder after 50 frames with a random variation of 10. So that's it for the antacid effect. As you can see, it's pretty cool. The end result looks relatively realistic. Could be better. As I said, if you used ray tracing to do the render, you could probably get a much more realistic result. It's easily adaptable to different effects. Like I said, people plunging into water, acid boiling, or even water boiling. You can just put emitters down the bottom. Use these large bubbling bubbles to come up from the bottom, and you could give this sort of percolating effect of oxygen bubbles coming up through the water. Okay, so let's move on from here on to our next example, which is quite good fun, where we've got animated arrows.